Welcome all to today's lecture. So today's lecture content will be about on fifth unit, that is friction and rigid body dynamics of the subject GE 8292, which is engineering mechanics as per Manchester syllabus. So today we are going to deal this topic called as friction. What is it friction means and its types? What are the laws of friction? So coefficient of friction, angle of friction and angle of repose. What all the terms means. So before going to definition and the types of friction, I just want you to imagine a scenario. You having two cases of moving a geometry box or any other object on two object. Imagine that you have a object which is going to place on the two surfaces. One is a very smooth surface and the other one is some rough surface. For example, normal floor of a home, or otherwise another case it will be having a tile floored surface. So you are going to apply a same amount of force on the object on the two cases, one on the tile surface as well as another for the rough surface. Can you imagine and tell me that in which case the object will be move more? Is obviously on the tile surface, right? So what is the reason behind that? If you sort out the reason behind this results, that is termed as called as friction. That is we are going to discuss in detail about this lecture. Yes, so normally what is the friction called as? And whenever two objects are in contact, there exerts a force at the point of contact or point of surface between these two surfaces, that will be tangential to that of the contact surface, and it opposes the force which is applied. So that is we are going to discuss friction in detail. Let me tell you detail in this. So consider this as an object which has some weight called as W, and this is a surface or ground surface where the object is placed on. So in this surface there is a contact between the object as well as the ground surface, where exists a force tangential, and the tangential force should be opposite to the of the applied force. This is some applied force. So this opposite force to that of applied force, what we termed as called as friction. What is the objective of this friction and what is the role of the friction forces? It just resists the object from motion from the applied force. When you apply the force, the object suddenly does not move and suddenly does not change its state of motion. It has some resistance with respect to the surface on which it is placed. That force is called as a friction force. So here is the definition. I would like to recommend you that to pause the video and write out the definition. So when two surfaces are in contact, the force which exert on the point of contact or otherwise the point of surface of the two surfaces, and its act tangential and opposite to the direction of applied force. It also termed as the frictional force is always opposite to not only to the applied force, and it also in the direction of the motion. For example, if you apply force on this object in this direction, what is the result? The object will going to move in this direction. Am I right? So the friction force developed between the object and surface should be in this direction, which is opposite to that of motion of the object. Is that clear? So this is termed as a frictional force. So yes, we have completed what the friction means and its definition. So now we move on to types of friction. So friction is broadly classified into two types. One is a static friction and other one is a dynamic friction. So what is the static friction means and dynamic friction is? So the dynamic friction is, in most cases it is also called as a kinetic friction also. So what is the static friction means and what is the dynamic friction? That's what we are going to discuss now. So consider the object named as A, which is placed on the surface. Now the object is at rest condition. It is in rest. So at this condition, there will be some frictional forces between this surface and the object, right? So that frictional force is called as a static friction force. That is before the object A moves over the surface or other body. It is not need not to be a surface over object over a surface. It may be also point of contact between two bodies, there also the friction may be exist. So in this case, object A is in rest. Now at this condition some frictional force is applied to the body by the surface or other body. So this frictional force is called as your static friction, right? Then what is meant by dynamic or kinetic friction? When the object A starts to move over, which may be a sliding motion or otherwise a rolling motion, whatever it may be. So whenever the motion starts, there will be a friction force between these two bodies or a body as well as a surface. That friction is called as a dynamic or kinetic friction. Hope you understand what's the difference between static friction and kinetic friction. So let me discuss it in detail with an experimental parameter. What does it means? Let us have a machine called as a force machine. We are going to apply a force using this machine to a object. The object is placed on a surface. So this surface is connected to a sensor called as a frictional sensor to measure friction, it means, right? So the relation between your applied force by the machine and the frictional force developed in the surface is measured by sensor is pictorially it is shown in this graph, where your applied force is in the y direction and as well as the frictional force in your x direction. What does it mean is, when you start applying some force, before going to this theoretical explanation, just imagine another scenario. You have a car which is under a breakdown condition. You have to move the car by pushing 2 or 3 persons, by using 2 or 3 persons. So at the start of conditions, the car won't move, right? So you have to apply some forces, the car is not moving. And again, when all the 3 persons or 4 persons who pushing the car, applied force is equal to or more than the resisting force between the car and the road surface where it is standing, then only the car starts to move. Is that right? Are you able to imagine that scenario? With the same scenario, come here. Here you have applied some force, the object is not moving, because the resistance force or the frictional force offered by the surface and the object is more than that of your applied force, so that the object remains the same condition, it is not moving. And then you are applied some more force, still the object is remaining same, right? So whenever the force applied by the force machine to the object overcomes the frictional force, then only the object starts to move. Is that clear? So that is the same condition here. Here is the first condition. You applied this amount of force, the frictional force developed will be this much. Your x coordinate will be the frictional force for this condition, for the some amount of force applied here, 1, right? So now you are applying some other force which is more than that of the first force. Here the frictional force developed will be more than that of in first case. It goes on like this to a certain condition. So up to certain condition, the force applied will be directly proportional to the frictional force developed by the surface and the object. So at certain condition, at a certain limit, after this limit, when you apply some forces, the frictional force, what is happening? There is some dip. This indicates that the object starts to move. Am I right? The object starts to move. Until it getting a steady state of motion, there will be having the decrease in the frictional force. So after the object attains the steady state of motion, the frictional force remains constant. So this region, can you able to see this region, the linear relationship between the applied force and frictional force? This limit will be calling as a static frictional force. Frictional force in the static condition. So this limit above which the frictional force is decreased, right? What this limit is called as maximum statical force, or otherwise called as a limiting friction. So the limiting friction also defined as the amount of friction which will be the amount of static friction is maximum. After that the motion, after this the object is going to start its motion, or otherwise called as the impending motion, which means the motion is about to start with the applied force. That is called as your impending motion. So at the impending motion, the frictional force will be your maximum of static force. It is called as a limiting friction. Is that clear? Yes. So after the limiting friction, there is a small decrease in your frictional force to attain the it leads the object to attain its constant speed or constant steady motion. So after the steady state is attained, the frictional force remains the constant, which will be called as a kinetic friction or dynamic friction. So these are all the three friction we are going to discuss. We are discussed as far with this experimental procedure. One is your static friction and another one is your kinetic friction. Third one is the maximum static friction, what we called as your limiting friction. Is that clear? So here it is the definitions. So static friction. So I would recommend to pause the video and have the definition for these frictional forces. So frictional force experienced by the body that it in contact with the fixed surface while it is in the static condition. Already said, right? So the body and surface are in contact and there is no motion and it is in a static condition. The friction developed in the static condition, what will be calling as a static friction, or otherwise simply what we call as a force of friction comes into action between two bodies before one body starts sliding over other, or sliding or rolling. Yes. So that is called as your static friction. And what is called as a limiting friction? Force of friction comes into action between two bodies when one body just start moving. This is an important word. And here before one body starts motion. That is what we discussed here, right? At the limiting friction, what happened? The body is about to start its motion, so it is gonna overcome the force of friction. So that is what here it is explained here in the term called as limiting friction. And the other one friction it is having, it is a kinetic friction, that is a force of friction between two bodies when a body is in a steady state of motion. So the frictional force between two bodies in a static condition is called as a static friction, and when a body is just start moving over another, at that time there will be a friction force which is called as your limiting friction. And when two bodies in a steady state of motion, the friction developed which is called as a kinetic friction. So these are all the types of friction we have discussed so far. Yes, so far we have discussed types of friction. One is a static, kinetic friction, and also the maximum static friction, what we call as a limiting friction. Now we are going to move over the topic called as laws of friction. So the magnitude of frictional force depends on parameters. What are the parameters? The frictional force depends on the direction of frictional force, and what are the parameters that the frictional force does not depend. These are all the laws we are going to discuss. So with respect to this topic concern, for our 5th unit of mechanics, we will be dealing only with the limiting friction. Most of the case we will be dealing only with the limiting friction. We are not going to deal with the dynamic friction or kinetic friction in this unit. So the laws of friction is most probably it is applicable to your limiting friction. So what are the laws? 1. The laws of friction state that limiting frictional force depends on the type of surface in contact and it does not depend on the area of the contact. This is the first case we discussed. You remember when an object is pushed over two types of surface. One is a tile surface and other one is a rough surface. Yes. So in the surface the area remains to be same. Yes. And other one is the object also remains to be same. Only the type of surface is the difference. One is a tile and other one is a rough surface. So the type of surface in contact is the depending parameter of your frictional force, and it does not depend on the area, because the area of the two cases also same, right? So the frictional force, change in frictional force, it does not depend on the area, it only depend on the type of surface, right? And in case of two objects, then it will be depend on the material of the body. In this case we have discussed so far is surface, over that there will be a body, right? If in case you have to dealing about the two bodies over which one is placed, so the friction developed between the two bodies, then the frictional force should be depend on the material of the body, right? So and then the frictional force is proportional to the normal force. Where the normal force comes from is your body weight. So we know that when a body is placed on a surface, due to the weight of the body, a normal force will be developed. So the frictional force developed between the surface and your object will be directly proportional to the normal. That is the law states. And third one is the direction of your frictional force that is developed between the surface and the object. So the frictional force will be acting tangential to the area in contact. When the surface and your body is in contact, the surface contact surface, right? This is this contact surface. The force, frictional force developed will be tangential to this surface in contact. And the direction of force we have already discussed. It should be in the opposite to the direction of applied force and as well as to the opposite to the direction of your motion. So these are all the four laws of your friction, or particularly these laws to be applicable to your limiting friction. One, the frictional force depends on the type of surface or the type of material, and it does not depend on the area of the contact. And third one is frictional force is proportional to the normal force developed by the body weight. And the fourth one is your direction. So the frictional force is acting tangential to the contact surface between the surface and body or between two bodies, and it also should be in the opposite direction of the applied force and the opposite to the direction of your motion of the object. Yes, the types of friction is over, and then we have discussed the laws of friction. So now we have to know about what is called as your coefficient of friction. So this parameter coefficient of friction will be changing with respect to the contact surface, material of contact surfaces. So what is the coefficient of friction? First, from the third law of frictional force, we can be derive the parameter called as your coefficient of friction. What does the third law says? The frictional force is proportional to your normal force, right? So that is what I have been written over here, where Ff is your frictional force, which is directly proportional to the normal force developed by the object. So to remove the proportionality, we will be giving some constant, am I right, which is called as your constant of proportionality. So for frictional force will be equal to that, this constant of proportionality is named as mu into n, where n is your normal force. This mu is called as a coefficient of friction. So what does the coefficient of friction means? It is the ratio of frictional force developed between two bodies and to that of your normal force developed by the body. So this mu is called as your coefficient of friction, right? So the two more topics we have to discuss is, one is your angle of friction and the other one is your angle of repose. The angle of friction is defined or mentioned using the term called theta, and the angle of repose is mentioned using the term called phi. What are they? Now we are going to see that. So angle of friction. So angle of friction is the angle between two forces. What are the forces? Now we are going to discuss that. So see in this diagram, you will be having a body, the body with the weight called W, which acting towards downward. So equal and opposite magnitude of normal force will be acting over this direction, which is called as normal n, and the object is applied force called as P is applied over a object. So with this applied force and with respect to this normal, we will be developing a force called a frictional force, which is acting over the direction tangential to the contact surface between the surface and body, and it is opposite to the direction of applied force called as F. So W is the object weight and P is the applied force, right? Now we are going to consider the two resisting forces, am I right? So N is the resisting force or resistance offered by the surface to the weight which is acting towards upward, and F is the resistance force offered by the surface to the applied force, right? So we are going to consider these two forces, frictional force and normal force. in a free body diagram manner. So it is little bit confusing, right? I am drawing here newly. So this is called as a frictional force FF acting towards your left side, and you will be having a normal force acting towards upward. Is that right? So see, this is towards the left side and this is towards a upward direction. So we know that now the what will be called as resultant force. How will be the resultant force acting? It should be towards your third quadrant, moving upward towards your third quadrant. So this will be your direction of your resultant force, right? So that is what I am mentioned here. So this is the frictional force and this is your normal force, and this will be your resultant force between the frictional force and normal force. Now what the term angle of friction means? So angle of friction theta means that angle made with the resultant of frictional force and normal with the normal force is called as the angle of friction, term that is a theta. Are you able to get that? Frictional force is acting towards left side and the normal force is acting towards your upward direction. The resultant will be, definitely it will be along your third quadrant, direction towards your third quadrant. So the angle of friction is the angle made by the resultant force between frictional force and the normal force with your normal force is called as your theta. So here using your triangle law of forces we have discussed in first unit, right? So this is your frictional force acting towards your left side and this is your normal force acting towards upward. So the resultant force will be in the closing direction. As with respect to your first unit, we have discussed triangle law of forces, which says that if the two forces are in adjacent sides, then the third force will be your along the closing side of the rectangle and opposite direction. So this direction and this direction, opposite direction means from is closing in this direction. This is the direction of your resultant force. So angle of friction is the angle between the resultant and normal. This is called as theta. Is that clear? So with this triangle, what will be the tan theta value? Tan theta is, we know that opposite by adjacent. So opposite is your frictional force and adjacent your normal force. So tan theta is termed as your frictional force by normal force. So this frictional force by normal force we already discussed somewhere. Yes? Are you able to recollect where it is? Yes, we discussed here coefficient of friction mu, which will be the ratio of frictional force and normal, the same term here. So tan theta will be equal to your mu. So this is called as your angle of friction. So what is the next angle we are going to discuss is angle of repose, which is termed as pi. What is called as angle of repose? So now imagine you are having a up to which we have discussed the plane is horizontal or surface is horizontal over which a body is placed. In this case we are going to discuss about the inclined plane or inclined surface above which your body is going to place. Are you able to imagine? See, this is the surface over which a body is placed with some certain, the inclined plane is making some angle with your horizontal line, right? So if an object is placed over here and you are going to incline the surface up to certain angle, the body can resist it, or otherwise the body can hold its the state of rest. Am I right? Up to certain angle when you incline the surface, the body can placed within that place itself. It does not move. But when you lift the or otherwise making an angle over increasing the angle, at certain angle what happen? This body will slides downward due to its body weight. Am I right? So that certain angle at which the body starts to slide downward. Are you able to understand? The certain angle at which the body starts to slide downward over the plane with the weight. Yes, we didn't apply any external forces. So the sliding is only because of due to its self weight and the certain angle made by the surface. So the angle at which the body starts to slide down is called as your angle, which is called as a angle of repose, pi. Is that clear? So in that, so if it is made pi angle is the inclined angle between the surface and the horizontal, so this will be your perpendicular motion, perpendicular to that of your surface, right? So your weight will be always act perpendicular to the body, it does not make some angle. So the weight is always falls downwards vertically, and this being your normal of your surface, the angle made between the weight and your normal of the surface will be as equal to that of your angle made by the surface over the horizontal surface. If this is pi, and the angle between the weight and your normal is also pi. Is that clear? Now the weight force being an inclined force with respect to this coordinates, if this is your x and y coordinate now changed, right? The before cases we have discussed the x and y as this cases where the surface is horizontal. Now the x is over this and y is over this, and your weight is acting straight vertical. So this is a inclined force comparing to these coordinates. So we know that very well that if it is having a inclined force, it has to be, if it is having a inclined force, we are going to divide it into two components. One is among the horizontal component and one among the vertical component. So the vertical component making an angle, so this will be your w cos pi. This is your vertical component, and this component will be your w sin pi, right? So with respect to the weight, the body is moving downwards, so the direction of motion is this. If the direction of motion is towards downwards, the frictional force should be in your opposite direction. This is your frictional force. Are you able to understand? So we are having four forces now. One is your w sin pi, which is the horizontal component of the weight, and w cos pi, which is the vertical component of the weight, and normal forces in the direction opposite to that of vertical component of your weight, and frictional force, which is the opposite to that of your direction of motion. These are all the four forces. So when you solve these four forces by your equilibrium condition, we know that summation of fx equal to 0 and summation of fy equal to 0, these being the equations for your equilibrium condition. So when you solve that fx equal to 0, what are all the forces on your horizontal component? One is frictional force and other one is w sin pi. Both are in opposite direction, so that f minus w sin pi equal to 0. So which will be say that frictional force is equal to w sin pi. Similarly, when you solve for this case, summation of fy equal to 0, you will be having normal force minus w cos phi. So normal force is equal to w cos phi. So this is equation number 1 and this is equation number 2. When you divide this equation, you will be getting the value ff by n on your left hand side, ff by n, and this is w sin pi by w cos pi, where w or cancel off, sin pi by cos pi will be giving your tan pi. And again this ratio we seen already that frictional force by normal is your coefficient of friction mu. So mu is equal to tan pi. And already we have discussed with respect to angle of friction mu equal to tan theta, which means mu equal to tan pi and mu equal to tan theta, which represent that tan theta is equal to tan pi, that theta is equal to pi, which means when your angle of repose will be equal to the angle of friction, then the object will starts to move downwards. This is the conclusion from this what we get. Is that clear? So that is, when your angle of repose will be equal to or greater than that of your angle of friction, then only the motion, then only that object can exist some motion. If the angle of repose is less than that of the friction angle, then the object is still in your rest condition, it does not move. So these are all the topics and definitions we have discussed so far. I thought you have a clear idea about what the friction means, types, laws of friction, and this coefficient of friction, angle of friction, and an angle of repose. So try to watch these videos and have a note and pen, write all these definitions and formulas. So with this definition and formulas, we will be dealing with some problems in the further lectures. Thank you. Keep learning. Have a good day.